Good day students, I am Dr. Smita Sharma and in this slide we will discuss differential amplifier working. In the previous slide we have discussed operational amplifier and its block diagram. So the topics covered in the previous slides were introduction to operational amplifier, its block diagram, basic introduction of a differential amplifier, how it is made and how input is added to the how input signal is provided to the differential amplifier, that is mode of application of input to the differential amplifier were discussed. In these slides we will discuss the working of a differential amplifier when input signal is applied to it. Now we know there are four modes of application of input to the differential amplifier. First of all we will discuss the first mode of application, that is when an input signal is provided to one end with respect to earth. Here in the diagram as it is observed, the basic differential amplifier is provided and input signal is being provided at the end terminal E1. So we will discuss when input signal is provided, what happens. Let an input AC signal is applied between base of Q1, input terminal 1 and ground. So when input signal goes positive, we know AC signal keeps on going positive to negative. So when input signal goes positive, what happens? The base of the transistor Q1 becomes more positive. As a result, the emitter collector current increases. As the emitter collector current increases, the potential drop at RC1 increases. So potential difference across load resistor RC1 increases. As a result, output voltage Vc1 available at terminal V1 goes less positive. This can be observed by equation given below. Vc1 is equals to Vcc minus Ic Rc1. Or thus we see for a positive going signal, we can say we obtain a negative going output voltage. Thus Q1 produces a negative going output when its input is positive. Similarly, we can say when input of Q1 goes negative, output turns positive. Thus, Q1 inverts the signal. This behavior is typically of a common emitter amplifier. But in a differential amplifier, another stage of Q2 is also connected to it. Now we will observe when input signal is applied to the base of the Q1, what happens to the second stage of Q2. At the same time, it is observed that as emitter collector current of Q1 increases, there is an equal amount of decrease in emitter collector current of Q2. This is because both draw current from a constant current source which maintains the sum of the emitter collector current of Q1 and Q2 at same value. So what happens? As emitter collector current of Q2 decreases, there is less drop in the load resistor RC2. So potential difference across load resistor RC2 decreases. As a result, output voltage Vc2 will increase. So we see decrease in emitter collector of Q2 results from increase in emitter collector current of Q1, which in turn was caused by positive going pulse. So in short, we can say when a positive going signal is applied at the base of Q1, we get a negative going pulse at the output of Q1, collector of Q1, and a positive going pulse at the output of collector Q2. So we finally say when positive going signal applied to Q1, we get an inverted signal as output at V1 and non-inverted signal as output at V2. In the same manner, we can discuss the second mode of application of the input. The second mode of application is when input is applied at the terminal E2 with respect to ground. As explained above, when input is applied only at input terminal E2 with respect to earth, when positive going signal is applied to Q2, we get an inverted signal as output at V2 and non-inverted signal as output at V1. As explained above, it is seen that both terminals are capable of establishing inverting and non-inverting signals. This should not be confused with op-amp, which has clear fixed two terminals, inverting input and non-inverting input. It is in an op-amp, it has two terminals clearly labeled, inverting denoted by symbol minus and non-inverting denoted by symbol plus. We cannot treat plus as minus and vice versa. The reason behind is in an op-amp, plus and minus to the input are given on the basis of final output of the amplifier. There is a chain of amplifier stages designed in such a way that input signal passing through the chain obtains inverted signal, so that input is named minus and vice versa. So, in a differential amplifier, both input can act as inverting and non-inverting, but in op-amp, clearly inverting and non-inverting inputs cannot be changed. Now we will take third and fourth mode of application of input signal. For this, we suppose a figure below represents the situation. A common input is applied to both E1 and E2, but there can be three possibilities. Either E1 and E2 are in same phase but are of different amplitude. In that case, output will be amplified version of the difference of the two inputs. Either it will be AD E2 minus E1 or E1 minus E2, depending on whichever is greater. The second possibility is E1 and E2 both are of same amplitude but are in opposite phase. In that case, the output will be AD E1 plus E2. And the third possibility arises when both are in same phase and are of equal amplitude. In that case, E1 is equals to E2 and V0 is equals to 0. This is common mode response of an ideal op-amp. So, we have in these slides we have discussed the mode, what happens when an input signal is provided to the differential amplifier, what changes appear when a signal is given to the differential amplifier. In the coming slides, we will discuss the DC analysis and AC analysis of the differential amplifier. Thank you.